Let's create contingency tables to interpret false positives or false negatives. So this gets into the fun stuff. Now, part of understanding false positives and false negatives is really just understanding what we're talking about. So in this table that I have, you can see we have disease is present or no disease, right? Because, let's talk about strep throat. You either have it or you don't, right? There is no in between. So if you take a test for that, you either are going to test positive or you're going to test negative. There's no in between, right? We're not talking about inconclusive, right? You're either positive or you're negative. So think about what you expect to happen. If I have strep throat and my doctor swabs my throat and does the strep test, I expect to test positive, right? We don't have a color here. So if the disease is present, I would expect to test positive. This is a true positive. In a similar fashion, if I do not have strep, I would expect to test negative. So no disease, negative test. This is a true negative. That should make sense in your head. This is what I expect to have happen. Okay, so let's go to the other ones then. Let's go to this box here. The disease is present. I have strep. I go to the doctor because my throat's killing me. They do the swab and they're like, nope, you don't have strep. I tested negative, but it's false. So if you test negative, but it's false, this is called a false negative. So I'm like, woohoo, no strep. I go around yelling at people, right, singing, spitting my germs everywhere, and all of a sudden everybody has strep. Okay, in a similar fashion, let's come down here. I do not have strep. I am healthy as a horse. I've just been talking too much, so I have sore throat. I go to the doctor, they swab, and they're like, ooh, you definitely have strep, right? So you test positive, but you're fine. So we would call this a false positive, right? So the idea is, how did you test? Okay, so it's either a true positive or a false negative. So if you test positive and you actually do have the disease, that's a true positive. If you test positive and you don't have the disease, that's a false positive. Okay, so false positive is you test positive, but you don't have it. And a false negative is you test negative, but you really do have it. So you can kind of think about what's worse. And if we think about COVID, I think a false negative is worse, right? Because you're like, oh, I don't have COVID, I'm fine. And then you go out and you talk to a bunch of people and then you just spread it everywhere. Really, that's with anything, whether it's the flu or strep throat or anything that causes people to not feel well. We don't really want to do that. So false negatives, I think, in that respect, are probably a little bit worse. Okay. So let's look at this. A new test is created to test patients for a new strain of malaria. A few trials have been conducted and results shown in the table below. Complete the table and answer the following questions. Okay, so the first thing we're going to do is we're going to find the values of A, B, C, and D. So let's start with value A. Well, we can say if I know the total of positive tests is 228 and 147 of them are actual positives or actually have malaria, then the difference between those, which happens to be 81. So 81 positive tests have no malaria. Okay, let's go to B. Well, now we can think of it this way. No malaria. There are 239 of those people. 81 of them test positive. That means the rest will test negative, which is 158. Go to letter C. Okay, so letter C, total, 161 plus 239, right? These are malaria plus non-malarias. Give me the total amount of people we are talking about. Let's get rid of my confusing math. And last, let's look at D. You can find this a couple ways. We can add the negative tests, 14 plus 158. You can subtract 400 minus 228. Doesn't matter how you do it. Either way, you get 172 total negative testers. Okay, so let's go to the next one. This is our table that we just found. We're going to do two questions. First one's up here. Find the probability of a false positive. Okay, now what does that mean? False positive means if you test positive, you don't have it. Right? That's what a false positive means. You tested positive. So that means we are looking at the positive testers. So there's 228 positive testers. How many of those are wrong? Well, 81, because 81 people do not have malaria, but they tested positive. So that's 81 over 228, which rounds to 0.355. Okay, so that's not what I wanted to have happen. Okay, we're just going to have to leave that up there. Okay, so then we're going to come down here to number 2, find the probability of a false negative. So that means if you test negative, it's wrong, right? Okay, so if you test negative, that means we're only looking at the negative tests. There's 172 of those. How many of those are wrong? Okay, because remember, if you test negative, you expect to not have malaria. This is true. If you test negative and you have malaria, that's where the false comes in. So 14 over 172 is 0.081. So roughly 8% of the negative tests are really you have malaria. Similarly, up here, 35% of the positive tests are not true, right? So 35 out of 100 people that test positive for malaria actually don't have it. Okay, now we're going to go into a little bit more of creating the table. So this might take a little bit more time, but if you need to know how to create a table, this is it. So many home pregnancy tests claim 99% accuracy. Let's assume that's true. If 1,000 pregnancy tests are taken, so that's a total of 1,000 pregnancy tests, and we know later that 76% of these people were not pregnant. Okay, 76% were not pregnant. Complete the table and answer the following questions. Okay, well, think about how this works. If we have 1,000 people and 76% were not pregnant, that means 760 people are not pregnant. And if we have 1,000 people and 760 are not pregnant, then 240 of them are pregnant. So the totals is where we start. Okay, I just got to see what this looks like. Okay, oh look, that's what I did. And now we use the accuracy rate. So the accuracy rate is 99%, meaning if I'm pregnant, 99% of the time, I'm going to test positive, right? So it impacts here. And if I'm not pregnant, then 99% of the time it's going to say you are not pregnant. So that's here, right? These are the true pieces. So if I have 240 pregnant people, 99% of the time it's going to come back that's correct. So 99% of 240 is 237.6. And because we are dealing with people, I'm going to go ahead and round to 238. You might want to check with how it's going, but I'm going to just use whole numbers here. So thinking through this, if I have 240 pregnant people and 238 of them tested positive, that means 2 test negative, right? Now let's go to my non-pregnants. If 760 people are not pregnant and 99% of the time it's accurate, 760 times 99% gives me 752.4. So I'm going to make that 752 for easy figuring. So once again, if I have 760 non-pregnant people and 752 of them test negative, that means 8 are testing positive. So let's add 238 plus 8 gives me 246 positive tests. And then when I add, I get 754 negative tests. All right, so I finished my table, and now we can find probabilities. Find the probability of a false negative. So that means given it's a negative test, you're pregnant, right? So given a negative test, 754, you are pregnant. That'd be a 2 out of 754 or 0.003. Very, very unlikely that if you test negative, I mean, it's possible, but very unlikely. Now, false positive, on the other hand, says, okay, you, right, given it's a positive result, you are not pregnant. So there's 246 positive results and 8 are not pregnant. So that's 0.0325. So roughly 3% of people who have a positive test are not pregnant. And that's creating the table and then interpreting false negatives and false positives.